start with the 8.1 rotational kinematics. Okay, so basically it's kita boleh terus compare rotational kinematics dengan linear kinematics. Alright, so sebelum ni kita dah discuss lah the angular displacement is analogous with displacement, angular velocity is analogous with velocity, right? And also the angular acceleration is analogous to the acceleration. Okay, all right, and then we have the relationship between linear and also rotational kinematics. So we have S equals to R theta, V equals to R omega, alpha equals ni A sepatutnya A equals to R alpha. Okay, dan kemudian you have this one A also. Centripetal acceleration is equals to R omega square. Okay, so ada sedikit perbezaan lah, right? Tapi yang kita gunakan dalam this chapter is this one yang paling banyak, S, V and also A. Alright, and then solve problems related to the rotational motion with constant angular acceleration. So this one is actually analogous to the equation. For example, you have V equals to U plus AT. Okay, so dia benda yang sama sahaja, cuma you convertkan daripada linear kepada rotational lah. Okay, so this one is S equals to UT plus half AT square. Okay, and then the last one we have V square equals to U square plus 2AS. Okay, so this is the linear equation, and then you convert sahaja dia punya symbol kepada angular velocity, angular acceleration and also angular displacement. So you can dapatlah rotational kinematics punya equation. Okay, so cara guna dia masih lagi sama seperti chapter 2. Okay, alright, and then kita tengok yang ni dulu 8.1. So now let's look at to the example. Kita tengok soalan terus. Okay, question number 1 over here. So a rigid body rotates about a fixed axis through a point in a body. So with uniform angular velocity 600 RPM. So this one nilai apa ni?
Omega.
Yes, very good. Omega. So you have omega equals with 600 RPM. Okay, so RPM stands for revolution per minute. So how to change into radian per second?
2 pi bagi 1 minit darab dengan 60.
1 minit darab dengan 60. Okay, so it means that what you have to do is times with 2 pi. Okay, maksudnya 1 revolution equals to 2 pi radian. So times with the 2 pi and then minute berada di bawah. So divide by 1 minute equals to 60 second. Okay, so 600 times 2 pi divide by 60. So baru you akan dapat nilai dalam radian per second. Okay, alright. So the velocity then decrease at a constant retardation to 300 RPM. Okay, so maksudnya yang kita dapat tadi, nilai omega tadi adalah omega naught. Okay, initial angular velocity. Alright, and then we have a final velocity. Okay, kita boleh letak omega sahaja. Kalau you nak letak omega F pun tak ada masalah, it depends. Okay, and then you have 300 RPM. So it means you need to convert to the radian per second lah. Okay, kita tengok dulu sebenarnya perlu ke tak, tapi kita try dulu. Okay, in 6 second. Okay, so dia bagi masa dekat sini second. So maksudnya memang kena tukarlah RPM tadi kepada radian per second. Okay, sebab dia bagi time T dekat sini is equals with 6 second. Okay, so the question, determine the angular acceleration. Okay, so dia minta nilai alpha. What is the angular acceleration? So kita tengok balik equation tadi. Kita dah ada omega naught, we have omega and we have T, and the question asks for alpha. So what is the equation, the most suitable equation that we can use?
The first equation.
Omega over T.
Over T. Number 1, number 2 or number 3?
Oh,
Number
1.
Yes, number 1. Okay, so this is the most suitable equation lah, sebab you dah ada omega naught, you dah ada omega final, and then it's given T. Soalan tanya alpha dekat sini. Alright, so the first equation yang paling sesuai lah. Okay, so you boleh terus masukkan sahaja dan you akan dapat jawapan. Alright, but remember again you need to convert daripada RPM kepada radian per second. Okay, alright, so next B. So the number of revolution the body has turned through in 6 seconds. So the question asks for what actually this one? Number of revolutions. Dia minta apa ni sebenarnya?
Theta.
Yes, very good. Soalan minta theta. What is the theta over here? Okay. So again, let's look at through the equation. Which one is the most suitable equation?
Second.
Yes, number 2. Equation, second equation. So you nak cari nilai theta dekat sini. But remember, okay, we already have omega naught dalam radian per second. Okay. And also alpha, of course, you akan dapat radian per second square. Okay, but the question asks for how many revolution. Okay, the number of revolution. Means that bila you cari nilai theta dekat sini, you akan dapat dalam unit radian. Okay, tapi soalan nak number of revolution. So you need to convert from radian to revolution. So what you have to do?
Divide by 2 pi.
Yes, very good. Divide by 2 pi. So always remember 1 revolution equals to 2 pi radian. Okay, so bila kita nak radian, maksudnya kita bawa lah 2 pi ke sini. So it means you need to divide by 2 pi. So you akan dapat dalam nilai revolution. Okay. Sama juga kalau next time you jumpa soalan the number of rotation. Okay, so maksudnya dia tanya nilai angular displacement. Okay, cuma dia nak dalam unit revolution. Okay, so the next one, C. The extra time needed by the body to come to stop if it continues to slow down at the same rate. Okay, so dekat sini dia tanya dia nak extra time. Okay, extra time bukan the time taken for the whole journey. Okay, dia nak extra time. Berapa lagi masa yang diperlukan to make sure that the body stop. Okay, so body stop maksudnya we have omega final kita equals to 0 lah. Alright, and dia sebut kat sini continue to slow down at the same rate. Maksudnya nilai alpha kita adalah nilai alpha yang sama. Okay, yang kita cari dekat sini. Kita gunakan nilai alpha yang kita dah kira tadi. Alright, so yang this one saya rasa tak ada masalah lah. Bila A, B you dah faham. So this one again you akan manipulate sahaja equation yang kita ada tadi 1, 2, 3. Pilih mana yang sesuai dan you akan cari nilai T tapi dia nak extra time. So extra time maksudnya you punya omega naught yang mana satu?
300.
300, very good. Okay, sebab dia nak daripada 300 tadi sampailah jadi stop the extra time tu sahaja. Okay, kalau dia nak total time maksudnya you kena ambil omega naught daripada 600 Okay, very good. Okay, so ini contoh soalan lah untuk subtopik 8.1. Okay, so you can nampak bila you dah buat dia lebih kurang sama sahaja macam linear, cuma daripada velocity contohnya you ada perkataan angular dekat depannya Okay. Alright, so soalan nombor 2 ni pun lebih kurang sama. So flywheel is accelerate uniformly from rest for 6 seconds. Okay, so dia accelerated from rest. So maksud from rest ni apa? What's the information that we have?
Omega naught dia 0.
Yes, very good. Omega naught equals to 0. Okay, and then it's given that T equals to 6 seconds. So it is observed that at the end of the 6 seconds, the flywheel rotates through an angle of 450 radians. So ni nilai apa?
Theta.
Yes, very good. This one is the theta, the angular displacement, and dia bagi dalam unit radian terus. So you can use directly lah. Okay, calculate for the flywheel. First one, angular velocity during the 6 seconds. So ni tanya apa ni? Soalan ni tanya apa?
Omega.
Yes. Okay, satu dia tanya average angular velocity. So average angular velocity kita ada equation omega final minus omega naught divided by time t. Okay, saya tak pasti dia dapat kat sini jawapan dia beza. Cuma saya rasa macam sama. Okay, and then the angular velocity at the end of the 6 seconds. So yang ni kita akan gunakan equation yang macam biasa tadilah. Okay, 1, 2, 3, pilih mana yang paling sesuai. Okay, so the first one, omega average, you need to calculate what is the final angular velocity. Okay, kemudian minus with the initial angular velocity 0 tadi tu, kemudian kena divide by delta t. So maksudnya you kena buat soalan B dulu dan you can answer question A lah, lebih kurang Nanti try, kalau ada masalah let me know. Okay, and the last one is the angular acceleration. Okay, so angular acceleration macam biasalah, pilih tadi equation 1, 2, 3 yang mana paling sesuai